Now friends, let us have a look at this topic, conversion of recurring numbers into fractions, right? So first, before going for the actual topic, I will give you a small example to know the importance of this concept. I am giving you a very small question. Find the answer for this expression 3.33 bar into 9. The options are, there are 4 options given to you, 30, 31, 32, 33. There are 4 options given to you, out of which one is the correct answer. So the expression is 3.33 bar into 9. What is the answer for this expression? Okay. So immediately you will tell, sir, 30 is the correct answer. That is correct also. 30 is the correct answer. And how you got that? Immediately what you will say, sir, 3.33 bar. First I am converting into fraction so that my simplification will be easy. 3.33 bar can be converted into 10 by 3. And then I will do 9 into 9, so 10 3s are 30. So this is how I did it. It is absolutely correct, no issues with it. But my question is, I am not interested in this answer. I am interested in the way you converted this fraction, this recurring digit number into this fraction. How did you convert it? आपने convert कैसे कर दिया 3.33 bar to 10 by 3? How did you convert it so instantly? Why? Because even a small kid also knows 10 by 3 करने से या फिर 100 by 33 you do, or else 1000 by 333 you do, you are going to get the same answer, that is 3.33 bar. Everybody knows it. Okay, 10 by 3 or 100 by 33 or 1000 by 333 will give the same answer called 3.33 bar. So that is why immediately you converted into fraction, you got the correct answer. But you know very well, in the competitive exams, nobody will give you these kind of easy fractions. Definitely you need to do you need to calculate, you have to apply your brain, you have to apply your logic, then only you will get that fraction. And moreover, one more thing, the BODMAS rule, then many mathematical operations are coming at once in an expression. We don't go by in a random way, right? We have a procedure. What is that? BODMAS rule. This is the basic rule. The full extended rule is VBODMAS. VBODMAS. What does this? You know about this BODMAS. And what is this V stand for? V stands for vinculum. V stands for vinculum. What is vinculum? Vinculum means bar or line. So in BODMAS, in full form of BODMAS also, V comes first. That means if any bar numbers are there, if any recurring digits are there, vinculum, bar, line, if any bar numbers are there, they should be operated first. Unless you clear that, you can't go into the BODMAS rule also. So without handling this V part, you cannot handle this BODMAS rules also. So this becomes very important. You cannot cancel directly bars, right? So you must calculate this V part, vinculum part. So you should know how to convert this recurring part into fraction part. Particularly where calc is not given to you, just like you know, most of the exams, except some exams like GATE exam, most of the exams you will not have calc with you whenever you are attempting aptitude questions. तो वहाँ पे तो बहुत compulsory हो जाता है. You have to know how to convert these recurring forms into fraction forms. Now we shall go into some examples and we shall see some questions. Afterwards we will understand the concept, and then I will tell you some shortcuts also, don't worry, how to convert these recurring forms into fraction forms in a very easy way, in a faster way. Okay friends, there are 3 numbers given to you to convert into fraction forms. That means P by Q forms you need to convert. First number is 27.17 bar. Second number is 27.217 bar. Third number is 0.0017 bar. These are the 3 numbers, right? So first number goes like 27.171717, so on like that. But second number is not like that. Bar is not there for 2. So bar started from 1. So it is like 27.2171717 and like that. So third number is 0.00171717. It goes on like that. Okay. So 3 different numbers. Second number and third number are like same, but the speciality of the third number is the value of this number is always greater than 0 and less than 1. In between 0 and 1 this is. Okay. Now if you go by procedure, friends, if you go by procedure, first I will tell you the procedure, then we can go for the shortcut, right? If you go by the procedure, they are asking you how to write this 27.17 bar as a P by Q form, right? So what I say, first you let this number be x. Let us suppose this bar number is x. So first what I am doing, I am multiplying with 100. 100x is equal. That means I am multiplying this bar number 27.17 bar into 100. What happens? The point shifts, right? So 2717.17 bar. 0.17 bar. Okay. Now again I am taking this x, which is the original number, 27.17 bar. Then I am subtracting. Why I am subtracting? Because my plan is to cancel this bar part. If I subtract like this, a bar part cancel ho jayega. That means 99x is equal to 2690. So obviously x is equal to 2690 divided by 99. This is the P by Q form. This is the P by Q form, 2690 by 99. If you want, you can check in your calci. 2690 by 99. Again, if you calculate it to get a answer, you will get 27.1717 bar. Now this is the actual method, mathematical method. Everybody knows why I did this, because I want to cancel this bar part. That's why I multiplied with 100 so that these two digits will come outside, and then I can cancel this bar part, so that the answer will purely become a natural number. After that, handling natural numbers is very easy. That is my plan actually. So everybody knows this. Now there are so many questions that rises from this procedure. Sir, is the procedure same for every question? Because second number is somewhat different. You don't have bar immediately after the decimal. And third one is entirely different. So not entirely different, just like the second number only, but it is in between 0 and 1. So is the procedure same for every number? First take the number x मान लीजिए उसे, then multiply with 100, subtract with x, subtract x from it, and then you get the number. No, numbers are different. Obviously methods also will be different. But you cannot remember hundreds of methods for hundreds of numbers, right? So you should have a common method, so that for any kind of number that they give, we should be able to solve them. So that is why now what I am going to do, I am going to teach you a shortcut which is applicable for all kind of numbers. Immediately after the decimal bar is there, or some gap is there in between 0 and 1. For everything, the coming shortcut will be applicable. That shortcut we will be learning now. Okay. Now friends, let us have a look at that shortcut that I told you to convert this kind of recurring numbers to fractions. Friends, first number we have taken is 27.17 bar. You need to convert it into P by Q form, right? Fraction. There is a numerator, there is a denominator. First we will have a look at the numerator part. In the numerator part, what you need to do, first write all the numbers from first to last without considering bars or decimals. Don't consider bars or don't consider decimal, just write all the numbers from first to last. 2717. Just write all the numbers from first to last. Minus, again write all the numbers from first to last, but up to where bars are not there. That means up to 7. Okay, जहाँ तक bars नहीं है, सिर्फ वही तक लिखना चाहिए आपको. Up to where bars are not there, up to there only you should write. That means up to 7 only bars are not there. So up to there only you should write. That means 27. Numerator part is complete. I will repeat the numerator part. First write all the numbers from first to last without considering bars or decimals. Minus, write numbers from first to last, but up to where there are no bars. Okay, so numerator part is complete. Now come to the denominator part. Friends, in the denominator part, we need to consider we are only concerned with what is there only after the point. Before point, what are the numbers? We are not concerned with them. After the point, what are the digits? How many digits are there? Only that is important for us. Friends, after the point, how many digits are there? First you tell me. There are 2 digits. So first give 2 slots. So give that many slots. Okay. So after the point, how many digits are there? That many slots you give. How to fill the slots we will discuss later. So after the point, 2 digits are there. So I have given 2 slots. Now how to fill the slots? My dear friends, after the point, there are 2 digits. That's why 2 slots are given. For after the point, for how many digits bar is there? You will say, sir, for both the digits bar is there. For both the digits bar is there. That bar status should be shown by number 9. That bar status should be shown by number 9. So 2 digits bar is there. For both the digits bar is there. That's why I have written 9. 2 9s. Because for both the numbers bar is there. So it means something like 2690 by 99. I think we got the same thing. Now again, if you want to verify this in your calc, you can verify 2690 by 99, you check it. Again, you will get the same answer, 27.1717. So once again, I'll repeat it. First, write the numbers from first to last without considering bars or decimals, minus write up to only those numbers up to where bars are not there. Now, that is numerator part. Denominator part, after the point, how many digits are there, that many slots you give. For how many digits bar is there, that many 9s you give. Okay, so then you got your P by Q form. Now immediately you will get a doubt. Sir, this question is not like that. Immediately after the point bar is not there. After the point, there are also some numbers without bars. There are also some numbers which are not having bars. Then how to deal with this issue? Okay, you tell me up to where you know. You tell me up to where you know, my dear friends. So 27.217 bar. Okay, so clearly I am writing 27217 minus, first I have written all the numbers. Now up to where bars are not there. So 272. Now how many digits are there after the point? How many digits are there after the point? 3 digits. That's why 3 slots. Now for how many digits bar is there? For only 2 digits. So first preference will go for bar status with a number 9. So 2 9s. Now second preference will go for without bars. That means for how many digits bars are there? For 2 digits bars are there. So 2 9s I have given. Now for how many digits bar is not there? For only 1 digit bar is not there. So second preference will go to without bar numbers with a number called 0. The status is shown by 0. So bar status is shown by 9. Without bar status is shown by 0. First preference will come for bar status. Second preference will come for without bar status. But here, without bar numbers are after the point, there are no numbers without bar. That's why I did not touch 0. But here there are some numbers after the point which are not having bar. That's why 0 came here. Understood? Now it will come like 26945 by 990. So if you further simplify it, you will get another fraction, right? Still, anyway, you simplify it, you will get this, again you will get this answer 27.217. Now coming to here, this question, this is actually the easiest one. It looks like tough, but this is the easiest one. So 0, 0, 0, 0, 0, 0, 3 zeros, 1, 7, minus 0, 0, 0. Not necessary. Minus 0 or plus 0 doesn't matter, but just for the sake of subject I am writing. So 4 digits. So I am giving 4 slots. For 2 digits bar is there, 2 9s. For 2 numbers bar is not there, 2 zeros. 17 by 9900 is the answer. 17 by 990 is the answer. This is the easiest way. The easiest way to convert the recurring digits into fractions. So this is not only for after the point, for every digit bar is there, after the point there is some numbers gap without bars, and then the bar has started, or if the value of that number is in between 0 and 1, anything, you can apply this method for any kind of number, recurring numbers, to convert them into fractions.